Hello everyone. Today I'm going to talk about data structures. So we know that we have some basic data types like integer, which are whole numbers, floats, which have decimals, or boolean, which is true or false, and characters, which is basically a letter. And however, sometimes we need to store multiple of these basic data types. So we have many data structures to store them in. So the first one is the very basic one, which is an array. An array is a linear data structure that is used to store elements of the same data type. So the key characteristics of an array are their fixed size, meaning we cannot easily change the size of the array, and we have to define it when we define the array. And they're having homogeneous elements, meaning it's of the same type, and they use index axes, meaning we use indexes like where the number is to access them. And they have contiguous memory allocation, meaning that they store next to each other in a memory. And there are a lot of advantages and limitations of arrays. So the advantages is that it is fast and the direct access to an element with their index. And it's very easy to use. It's very common to use an array, and it's very easy to set it up. And disadvantages is that it has a fixed size, so that means that adding and removing elements are costly and inefficient, and it cannot store different data types. So the second one is linked list. A linked list is a data structure where each data item is connected through pointers and it is not stored continuously like in arrays. So for each node in a linked list, there is data that stores the information and a pointer that points to the next node. So the characteristics of a linked list is that it is a sequential access, it has a dynamic size, and it is non-continuous. This is an example of a linked list. We can see the node, one node which has a data, and the next, which the next stores the pointer which points to the next data type, and so on. So what are the advantages and limitations of linked list? So the advantages is that it has dynamic memory allocation, meaning that it does not have to store next to each other, and you can really just save a lot of memory, and you can add or remove elements easily. And the second is efficient insertions and deletions. So we can just manipulate the pointers. We can, for example, if we add an element, we could just change the pointer from the previous element to this element, and this element to the previous next. So we can easily insert and delete elements. So the disadvantage is that it has extra memory usage. You see that we have to have another which now have to store the pointer, which would also take up memory. And it has sequential access only, meaning that we can't access it through indexes. We have to go through the whole linked list to find the number we want. And it is hard to traverse backward, since normally we only have one pointer which points to the next element. But there's also a double-ended linked list which has both ways, but that's another story. And then there is stack. A stack is an abstract data type that follows last in, first out order. It has a pointer that points to the top of the stack that allows push and pop functions. So characteristics of stacks is that it is last in, first out. It has a single access point, and it has possible overflow. So what does it mean by last in, first out? So we have the picture here. So for example, we add a number 5 to the stack, it will be here. And this is last in. And the way we try to access, we will access the last in element, which is the 5. We can do stuff with that. We can pop it, or we can access that number. So that means it's last in, first out. And it has only a single access point, meaning we only can access with the pointer of the top, and that possible overflow. So there are a lot of usage of stacks. Normally we use it for like in real life with undo redo function, like Control C, Control V. And browser history, which like we use Control Shift T to open the previous open tabs. So it's that's in the last in first out format. And also function call management like recursion or nested functions. You normally store them in a stack to when we recall the recursion. And another data type is the queue. A queue is an abstract data type that follows first in, first out. It is like waiting in a line at a cafe. The first person who lines up will be the first to order. It has two access points, the front and the rear, and can perform enqueue and dequeue operations. So this is a picture of a queue. We can see there's the front and the rear, and then we can have 2 pointers. So there are 3 types of queues we normally use. The first one is a simple or linear queue, which is just an array and which stores numbers, and when we remove numbers, we remove from the end by moving the pointer one place forward, and if you want to add elements, we move the front pointer forward and change the number in that array. And since this doesn't have any circular, so you can be overflow, meaning you reach the end of the array. And there's also a circular queue where it's unlimited, since we can just when it goes to the end of the array, we'll come back to the start of the array. And this double-ended queue or dequeue, where we can access both ends, so we can move both ends forward or backwards. And the usage of queues in real life. So there's job scheduling in operational systems, a breadth-first search in graphs, to-do lists, or managing waiting lines. They're all, as you imagine, queue, as in waiting in a line. And that's all. Thank you for listening.